Okay, let's do another example of our applications of these systems of equations. This time we've got another problem. This is sort of like a mixture problem if you think about it. In this case, a sheet metal shop ordered 60 pounds of tin and 30 pounds of zinc alloy for a total of $960. Presumably they combine these together to make a new new type of metal that they can use in whatever work they do. So the first purchase was $960, but then they made a second purchase. They made a second purchase at the same prices to include 40 pounds of tin and 70 pounds of zinc alloy. That's just the alloy, where I can't really spell very well here, for a total of 1,540. Find the cost per pound of the tin and the zinc alloy. So the very first thing you do, like any good book, sometimes I like to start from the conclusion onward, and it's the conclusion right here is, well, the cost per pound, right? We want to always identify your variables first. That's always the best habit if you're dealing with a word problem. Identify what you're solving for and label it. So, all right, let's label right here. Let's say that our cost of tin, so cost per pound of tin, cost per pound of tin. I don't know what that is, but let's call it X since we're in the habit of calling things X and Y around here. And we also want to look at the cost per pound, this time of zinc. Right? And we'll call that Y. Right, so we got our X and Y right here. Those are our costs per pound. Now, how do we use this? Well, turns out, I guess, that if we want to get a cost of something, we're going to take the amount of that something, whatever it is, we're going to multiply that by the cost per pound, right? The cost per pound right here. And when we multiply those two, our model tells us that the amount of the stuff in pounds times the cost per pound will give us the total cost. Only our cost has two parts. Right, so let's look at it. So let's put this down in purchases. So let's look at purchase one. The first purchase of metal. What did they do? Well, in purchase number one, they took 60 pounds of tin. Right, so we've got our tin at a cost of X dollars per pound. We don't know how much that is, but its cost is 60 times X dollars. And then we also ordered 30 pounds of zinc at a cost of Y dollars per pound. So that gave us a total cost of 30 Y. Right? Now, actually, put that all together, that comes out to a total purchase of $960. Right? So our first purchase came to $960. And that actually gives us an equation right here, right? 60x plus 30y is equal to 960. All right, so now let's take a look at the second purchase. All right, so we've got purchase number two. Purchase two. All right, and in purchase two, what did we do? Well, we took our amount. In this case, we took 40 pounds of tin at X dollars per pound and got 40 times X dollars for that part of the purchase. And we ordered 70 pounds of zinc alloy, to give us a total cost of 70 Y dollars. And of course, when we add those together, we should end up with a total cost of $1,540. Right? And now if we add down the column, we've actually got another system of equations. And here it is, 40x plus 70y equals 1,540. All right, now let me teach you guys a trick, because a lot of people will just try to power through all of their calculations with the zeros attached right here. Here's the secret. If each of these numbers are divisible, end in a 0, then they're all divisible by 10. So if you divide both sides of each equation by 10, you're going to get a completely equivalent system of equations here, right? So it's divisible by 10, right? And you can always tell it's divisible by 10 if we end in a 0. If we divide everything by 10, what do we have? Well, we have the system 6x plus 3y equals 96 as the equivalent to the first equation, and 4x plus 7y equals 154 for the second equation. Now, I don't know about you. Maybe you like those big numbers and powering through them, but it does kind of waste a little bit of time trying to track all those zeros. And these numbers are a little bit easier to work with, right? If we had this system of equations, how would we solve it? Well, we're going to take equation 1 here and equation 2, and somehow we have to add things together so that something drops out. And I'll tell you that 6 and 4 both divide evenly into 12, right? So it would be very easy to find us a factor that we could multiply by 6 and 4 to get 12 and negative 12 respectively, so that we can do some subtraction here. So let's do that. Let's try, and I'm going to start doing my work over here. Let's try taking, let's see, what do we have to do? We have to take negative 2 times everything in equation 1 and add that to, let's see, to get 12, 3 times everything in equation 2. And what that's going to do is that's going to eliminate, we're going to eliminate x that way, right? So when we add these things together. So all right, let's take our first equation. Multiply everything in it by negative 2, right? So let's see. Negative 2 times 6 gives us negative 12x. Negative 2 times 3 gives us negative 6y. And I'm writing it as plus negative 6y, but you get the idea. Equals, let's see, negative 2 times 96. Well, you should probably do this work off to the side. I'll give you a moment. All right, when I multiplied together, I got negative 192. Negative 192. And then I took my second equation, took every one of those terms by 3. So let's see, 3 times 4, that's positive 12x. Well, that's what we wanted. We're going to drop that x out of the equation. Plus 3 times 7y over here. That's, we're taking 3 times this. 3 times 7y gives us plus 21y. And 154 times 3, well, I did my multiplication right there, and I got 462. Maybe you just paused and tried that out yourself, at least I hope. So now when we add these two equations down the column, 12x, negative 12x, that just drops out. And we're left with 21y minus 6y, which is the same as 15 times y, is equal to 462 minus 192. Adding those guys together gives me 270. So now I'm going to divide everything by 15. I'm going to divide by 15 right here. And if you do the division here, I don't know if you guys recognize the terms. 270 divided by 15. Well, let's see. Both of these guys are divisible by 3. 27 divided by 3 is 9, so this is 90. And of course, it's a 90. Not an 80. Good Lord, boy, I can't write today. 90. 15 divided by 3 would be 3. So it would be 5, right? So let's see, 90 divided by 5. Well, that gives me 18. Right? So I find y is equal to 18. And so now I can go up here and I can solve for x using one of my two original equations. I'm going to use that first one. 6 times x plus 3 times y, in this case that's 18, will equal 96. So working this out, let's see, 6x plus 3 times 18 becomes 54. That still equals 96. So I subtract my 54 from both sides. I get 6x is equal to let's see, 6x divided by minus 54, 242. So I divide everything by 6. I divide everything by 6, and I come up with x is equal to 7. Am I done yet? No, you bet it. We got to answer the question. So what is our costs per pound? Well, the costs are for the tin X, that's going to be, it's going to cost us $7 per pound. And for our zinc is going to cost us, looks like, $18 per pound. More in the next video.